Okay, so it says finding all real roots. And I want to clarify something before we start, is the idea of imaginary numbers. So I is seen as the square root of negative 1. In other words, I squared is the number negative 1. Okay, there's no number you can multiply by itself to get that negative 1. And so we have imaginary numbers. We're going to avoid those in what we're doing with all this. That's what the part I was trying to relay to you here when I talk about finding real roots. Alrighty then. So what are the real cube roots of 0.08, negative 1,000, and 1/27th? Cube roots, right? So 0.008 is technically 0.2 cubed. So 0.2 is the only real cube root of 0.008. Negative 1,000 is negative 10 times negative 10 times negative 10. So negative 10 is the only real cube root of negative 1,000. 1/27th is 1/3 times 1/3 times 1/3. So 1/3 is the only real cube root of 1/27th. So we talk about fourth roots. What are the real fourth roots of 1? 1, let's see, with tenths, hundreds, thousands, millions, right? Or no, tenths, hundreds, thousands, 10,000s. There we go. What the heck? So what are the real fourth roots of 1, negative 1/10,000th, and 16/81st? Since 1 is positive, there are 2 real fourth roots. And we talked about this, the positive negative thing at the beginning here. So because, now this is where, it does catch folks up. They tend to ignore one of these. So obviously 1 times 1 times 1 times 1 is 1. But so that works the same for negative 1. Negative 1 times negative 1 times negative 1 times negative 1 is the other real fourth root of negative 1. Now, since, again, 1/10,000th is negative, there are no real fourth roots of negative 1/10,000th. Since 16/81st is positive, there are 2 real fourth roots. We have the positive 2/3 and negative 2/3 again. That's the one that folks tend to forget. Now again, negatives have cube roots, right? Have cube roots, I should say, but negatives do not have fourth roots or square roots or that sort of thing if we're trying to stick to real numbers. Hopefully you're catching on to the idea here, the even and odd version of roots and how that plays into this. What are the real fifth roots of 0, negative 1, and 32? Well, 0, right, is its own real fifth root. That one's kind of nice, just like 1 would be. So again, fifth roots, what we're looking at here is the idea that negative 1, right, to the fifth power, or I'm sorry, 0. I don't know why I started putting negative 1. So again, 0 to that fifth power, right? 0 times 0 times 0 times 0. Did I say it 5 times? Is 0. So it's its own real fifth root. So again, we can write like fifth root, right? So that one worked out pretty easily. Negative 1, same kind of story here, right? We know that negative 1 times negative 1 times negative 1 times negative 1 times negative 1, that's 5 times, is still negative 1. So it's its own fifth root. 32, right? We have 2 times 2 times 2, messed up that parentheses, times 2 gives us 32. Now, can we say the same thing for negatives, right? If I were to instead say, oh, what about negative 2 times negative 2? If each of these was negative instead? No, that's not true because that would be negative 32. So in that case, again, hopefully you're catching this pattern even in odds when it comes to that. So the negative idea does not play out in all of this when we have odd roots that we're looking for here. And then we have the idea of 36/21. And that looks like this. So again, when you think about this, in order to find this, you would want to know the Oh, I'm sorry, that's the next one. What are the real square roots where they're not fifth roots? I thought I was thinking that was one of the fifth roots here. Let me make some room. Alrighty. So B here, I'm gonna have to make a little bit of room. What are the real square roots, right? Square roots. So when we think about points, so let's take a look at 0.01 here. Well, isn't that 0.1 times 0.1? But again, we're looking for an even root. So technically, we also get negative 0.1, right? Negative 0.1. So those are the real square roots for 0.01. Negative 1. Now, I kind of mentioned this early on. There's nothing you can multiply by itself when you have a negative like this in order to get a square root. Again, that's that whole I, that imaginary number concept. We don't have that yet. Okay, then moving on to 36/21st, or 121st, sorry about that. Think about the top and bottom separately, right? Square root of 36, square root of 121. Well, for sure, we get 6/11ths, but again, don't you also have negative 6? Because you can multiply negative 6 times negative 6 and negative 11, right? Oh, you got to pick, well, I guess one or the other, right? So, and then 11 times 11, you can't make them both negative. That makes it positive again. And then 11 times 11, so technically, isn't negative 6/11ths also a square root of this, since the multiplying that negative times the negative makes it positive again. So we have two real square roots there, negative and positive 6/11ths. And finally, let's get down to the got it C here. Explain why a real negative number B has no real nth roots if n is even. And again, that gets at the whole heart of everything we've been talking about here, is that any negative number multiplied by itself is an even number of times, will always be positive. Therefore, there can be no real nth roots where n is even, again, for a negative number B. In other words, the negative's wiped out, right? When you square it, or when you multiply it to the fourth power or to the sixth, anything even wipes out the negative. So you can't have a negative for the nth root of that. Okay, so let's talk about finding roots here. And part of this, I'm going to hope I make it clear as we go. First off, cube root of negative 8. So that's negative 2 times negative 2 times negative 2. No other number satisfies that. So the only real root here for this cube root of negative 8 is negative 2. Now, 0.04. 0.2 squared is clearly 0.04. We also know, though, that if I were to pick negative 0.2, right, and square that, that would also satisfy it. But we are concerned primarily with the principal square root. That's the positive square root. And this is that whole nth root of nth powers thing that I'm discussing a couple of slides with you to try to clarify it for you, kind of put it out there. So again, only we're only looking for the principal square root, the 0.2. Fourth root of negative 1, there is no real root. We talked about that with the whole I thing in imaginary numbers. Nothing works there. And then D, now this one I want to encourage you before you, because you might go, oh, negative 2, right? And positive 2. But simplify it before you do anything. So we know that negative 2 squared is 4, and the square root of 4 is 2. Now again, we do know negative 2 satisfy that, but because of the property of nth roots of nth powers, we only want the principal square root. Okay? Hope that makes sense. Again, a couple slides, I'm going to touch on that again after we go through the got it's for this one. Alrighty, so taking a look here, what is each real number root? So talking about the cubed root of negative 27, obviously negative 3 times negative 3 times negative 3 is the only number that satisfies it. B, again, we're trying to take an even root of a negative. It's not going to work. Nothing will satisfy that. Nothing. C, like we mentioned in the last one, you need to simplify before you do anything. So we're looking at the square root of 49, technically, which is 7. And again, I know negative 7 satisfies that, but again, we're looking for the principal square root, and I'll make that clearer here in the next slide. Moving on, trying to take a square root of negative 49. That's an even root of a negative number. No such thing. All right, I'm going to make a point of clarification. I don't think I wouldn't call it misrepresented, but I want to talk about the positive and negative square roots. But we're going to talk about the principal square root and the difference in these two things. These may seem very similar to you. The square root of 4 is 2, and we also know that negative 2 satisfies that. But 2 is the principal square root. Okay? Now, so that means technically we're supposed to, again, according to the nth root of nth powers, you're supposed to ignore it. Except in a situation where a variable is involved. Okay, this is where it gets sticky and where I will promise you I will be nice to you when we're grading things. So here's the idea. If I go to solve this x squared, right, I would take the square root of 4 and the square root of x squared. And then I would say x equals. This case, I would say 2 and negative 2 both, because in an equation format, both satisfy the equation. 2 and negative 2 both satisfy the equation. So when a variable is involved, we will take the principal and the negative square root. When there is no variable involved, like this, we will take the principal square root only, which would be nice for those of you who forget to write the second one. So there you go. Hope that's a point of clarification. I do apologize if it sounded as though I was misleading the last two slides, but I wanted to kind of get that idea in your brain of, like 49 having 7 and negative 7 as square roots. But again, according to the property of nth roots of nth powers, this is where only if there's a variable involved, right, do we go ahead and need the absolute value. That's what the absolute value sign shows up, that you just take the absolute value when there's not a variable involved. So my son Noah is sitting here with me, and this is the kid that took geometry as an 8th grader and was doing algebra when he was 4 and loves math, and he is arguing with me saying that's wrong and it's not right. I'm reading a couple of websites right now, and they're saying, no, this is true, this is the way it's done. But again, I as your teacher will be understanding if you make an error either direction in it. Please do know that. He's even making huffing noises at me like he's disgusted. Alrighty, so simplifying radical expressions. Here's where it starts getting fun. What is a simpler form of each radical expression? Okay, so, and again, we have lots of rules behind us we've learned to help us through this stuff. We know that the square root of 16x to the 8th power, we can look at the idea of, well, square root of 16 is 4, right? And the square root of x to the 8th power is x to the 4th power. And we take the absolute value of that, technically, not exactly necessary here, because that 4th root is going to kill it anyway, no matter what negative I put in there, right? So, but technically, nth root to the nth power says it comes out absolute value because of the even n there, right? But again, that squaring is going to kill it, so, or the fourthing, if you want to call it, I guess. Need to include, again, absolute value symbols because the index of the square root is 2, which is even. However, again, x to the 4th is always going to be non-negative anyway. Alrighty. Moving along, b, cube root of a to the 6th, b to the 9th. Cube root of a to the 6th is a squared. Cube root of b to the 9th is b cubed. And again, this is an odd index, right? Therefore, we don't need the absolute value signs. And so those come out as a squared, b cubed. Again, the index is odd, so you do not need the absolute value symbols here. This is more that nth root, nth power thing. Okay, moving on. Now again, the index here is even. Therefore, you know that there will be absolute value symbols involved, which had you left them up here, by the way, I would have been okay with it. I would not have counted it against you. Alrighty. So, we know the 4th root of x to the 8th power is x squared. The 4th root of y to the 12th power is y cubed. So we can say that the 4th root of this whole thing, and you can put them together there, obviously, since they're 4th roots, is x squared y cubed. And we know because, again, this is an even power, it doesn't necessitate having the absolute value. But because this one is an odd power, it does to keep us from getting that extraneous solution there. And plugging back in numbers, when we move into that, you see, oh yeah, that's definitely an extraneous solution here. Okay, so, and I even brought the property along for the ride this time, put it at the bottom there. So, the square root of 81x to the fourth. Again, we know the square root of 81 is 9. The square root of x fourth is x squared. And again, because this power, technically, you can make this 9 absolute value of x squared, but it's not necessary because the squaring would kill any negatives. So, this would be an acceptable answer. Over here, we have the cube root of a to the 12th and b to the 15th. So a to the 12th is a to the 4th times a to the 4th times a to the 4th. So the cube root of a to the 12th is a to the 4th. And b to the 15th, well, that's b to the 5th times b to the 5th times b to the 5th. So that's b to the 5th. And again, because the index is odd, we don't need the absolute value to protect it here. And that's maybe one way to think about it. If I throw that in there, maybe that'll help it stick in your head. And now here again, index is even, so you're going to need some absolute value involved here. We know that the fourth root of x to the 12th is x cubed times x cubed times x cubed times x cubed. If I can spit that out. And the fourth root of y to the 16th is clearly y to the 4th. But again, because the index is even, we have to think, oh, do I need an absolute value? And we're going to throw an absolute value around the one that has the odd power. And you can see that written nice and clear down here if that helps on all those. So there we go. If you need help, need questions on this, please do ask. All right, you knew it was coming. Story problems, I love them. All right. Some teachers adjust test scores when a test is difficult. It's called curving. I just kind of push your points up a little bit. One teacher's formula for adjusting scores, A equals 10 times the square root of r, where A is the adjusted score and r is the raw score. If the raw scores on one test range from 36 to 90, what is the range of adjusted scores? In other words, plug 36 and 90 into this formula, right? And again, we're looking for the principal square roots, just so we're clear on that part, because there's no variable involved. So 10 times, and there's the bottom score of 36. So we take 30 squared to 36 is 6. 10 times 6 is 60. Well, that's nice. I'm not doing this, by the way. And then we throw in 90. The square root of 90 is about 9.5-ish. Times 10 is 95. Again, not doing this. The adjusted scores range from 60 to 95. All right, same thing, right? We're going to take that A, that adjusted score is 10 times the square root of the raw score R. They want to know, what about 0 and 100? Well, if a kid gets a 0, they're still getting one. Sorry. So adjusted score of 10 times the square root of 0, always still 0. Plug in 100, right? 10 times the square root of 100. And again, the principal square root of 100 is 10, so 10 times 10, still 100. Did nothing for that kid. Nothing at all. So sorry. Seems to do a lot for the kids on the lower end, though. Or like say that 36 got bumped up to a 60, right? But doesn't do as much for the upper end.